Hello, my name is Charlie Dordan, and today I'll be presenting on valuation methodology analysis for big game hunting. To introduce this topic, I present the broad research question. My broad research question is there a difference in outdoor recreation valuation estimates when using different valuation methodologies? To approach this question, it is important to have a little background. Valuing outdoor recreation is a form of non-market valuation. Non-market valuation refers to assigning economic valuation to goods or services that cannot be traded in a market. Since outdoor recreation cannot directly be traded in a market, non-market valuation techniques are used to find values for it. Two different methods of finding non-market values are stated and revealed preference methodology. Stated preference estimation uses hypothetical context and choice alternatives to calculate non-market values, and revealed preference estimation uses observed and existing information to calculate non-market values. Some instances where these methods are useful are presented in literature on the topic. For instance, having a better understanding of the demand for hunting trips can better inform decision-making for allocation of funds. These can also help provide further knowledge on ways to generate revenue for wildlife agencies. As I delve into this analysis, I present the more precise research question. This is, when using revealed preference methodology versus stated preference methodology, is there a difference in consumer surplus estimates for big game hunting in North America? To answer this question, it is important to understand the hypothetical bias. Hypothetical bias is when individuals answer hypothetical questions with responses overvaluing their willingness to pay or providing a willingness to pay value they would not pay at all. Additionally, some examples of big game in North America include moose, black bear, grizzly bear, deer, bighorn sheep, elk, American bison, and the American alligator. And this brings me to my hypothesis. If consumer surplus estimates are evaluated for big game hunters, then stated preference estimates will be greater than revealed preference estimates, because individuals tend to overprice their actions through stated preference estimates. Moving on to the methods section, the study area included for this analysis is the United States and Canada. The large study area is due to the fact that the data comes from a metadata database. The Recreational Use Value Database, or RUVD, contains recreational use values from 421 different economic valuation studies between the years 1958 to 2015. A subset of this metadata file that focuses on individuals engaged in the activity of hunting big game is used in this analysis. This subset of data includes 519 observations from the years 1964 to 2009. So the methods continued. The data is analyzed through simple linear regression using the ordinary least squares method, and the t-test is performed at the 5% significance level to determine if the estimated coefficient values for the independent variables are statistically significant. The adjusted r-squared value is calculated to determine the explanatory power of the regression. And lastly, the f-test is performed at the 5% significance level to determine if the entire regression is statistically significant. So moving on to the results, the table presents the descriptive statistics for this analysis, and I'm going to pick out some key values to look at. The mean consumer surplus estimate in real 2016 US dollars is $78.12, while the minimum is $5.06 and the maximum is $576.19. So basically there's a lot of variation in this variable. 74.57% of the estimates are calculated through stated preference methodology, and 25.44% of the estimates are calculated through revealed preference methodology. And the trend variable indicates that the data ranged over a time period of 45 years. So continuing with the results section, the presented table indicates regression results for three model specifications. The first model regresses consumer surplus estimates as a function of the stated preference dummy variable that controls for valuation method. The second model regresses consumer surplus estimates as a function of the stated preference dummy variable and also the trend variable that controls for years. The third model presents the best regression and regresses consumer surplus estimates as a function of both these variables plus an interactive variable of both of them combined. All three regressions present low explanatory power shown through the adjusted r-squared values. However, the f statistic increases throughout the regressions. As we move to the discussion of these variables, it is important to note that none of the regressions were statistically significant at the 5% significance level. However, the results did indicate without statistical significance that stated preference estimates provide greater willingness to pay estimates than revealed preference estimates. This is evident by the positive sign in front of the stated preference dummy variable. This regression agrees with the hypothesis. Also, in the third model, the trend variable indicates that with every successive year, the consumer surplus estimates increase for big game hunting. This means that individuals are willing to pay more every year. Additionally, the interactive variable indicates that with each year a stated preference estimate was made, the estimates decrease. This could possibly indicate the increased precision of these estimates over time and the decrease of the hypothetical bias. So what do these results mean in the broader context of things? The results of the interactive variable indicate that there has been an increase in the accuracy of stated preference estimates over time. As they more closely move toward the values of revealed preference estimates, they are typically thought to be more precise. However, there is more room for improvement in these valuation techniques. Overall, these kind of estimates can benefit informed decision-making in wildlife policy and other applications, and having a more balanced use of our resources can benefit environmental systems as a whole. And that is it for my presentation. These are the URLs for the pictures, and thank you for listening.